So we're going to open our existing model, the model that we already built. So we're going to select the existing model icon. Then I'm going to open the browser to select the file. I will browse to the folder where I saved my model. Our model was named projectile_1. So I'm going to select open. Make sure we have this checkbox selected, so any intermediate file will be saved in the same directory. If I click OK, then Adams is going to load the model. It may take a while, depending on your computer. It may take a few seconds, and sometimes it take, depending on the graphics and depending on the time, the model that you have. Adams will load your model at the same stage that you left it last time. So here is our model, here is our measures, here is my model loaded. I have the projectile body and I have the measures that I built last time. It took a while to load the model, but now I have the model is up and running. Okay, so sometimes when you save the model as database, this model is going to take large space of your hard drive. The database usually contains everything about the graphics, about the results, about the simulation, about the plots that you have, and that's why it is large. But in many times, especially when you are building your model, you don't want to save all the intermediate results. So instead of saving Adams as a database, we can export Adams as a text file, and this text file will be a very small text file. At the same time, you can share it with other colleagues. Also, you can, when you load it, most of the time it will be very easy to load. In order to save this model, this file is usually called Adams command file. So the way we do this, we go to File. I would like you to do this with me. So I'm going to go under File and select Export. When you select the export, this is going to be the default export. If you look under the file type, there is a pull down menu, and here you have all the different options for exporting files from Adams. Right now we are going to focus only on the Adams view command file. Other options, we'll talk about them if we get a chance to do this. In order to do it again, I'm going to repeat. We'll go under File, select Export, and here you'll see Adams view command file. And then you have the file name. This is the file name that I have that will be exported. And the model that is going to be exported is our projectile model. This is the one that we have open right now, and this is what we are going to export. Now if you click on OK, Adams is going to save a text file. So if I would like to look at the contents of this text file, I can go to the working directory where I have my model was opened. So this is my working directory here, and as you can see, this is our projectile.pin. This is our Adams database, and then you can see projectile1.cmd. CMD stands for command, and this extension is actually reserved for Windows, but you can edit this file. If you would like to edit the file, you can open the file as a text file. You can right click on the file and it will give you options. What do you want to do with this file? What I would like you to notice here is the size of the file. The database, the binary database is 10 megabytes, almost 10 megabytes, while the command file is only 6K, which is very easy to handle and manipulate. Now you can open this file, you can edit the file. If you select edit, it will open it in text editor like this. This is the Notepad text editor, and as you can see, this command file is actually contains something that looks like English language that we use in our daily life. It's not the topic of our session today, but I would like you to look at some of the contents. You can see that the file is divided into some kind of blocks, and every block contains certain amount of data. So here we have the first block starts with the units. So this is how we set the units, and if you remember, we choose millimeter, kilogram, second. So you have the length, angle, force, mass, and time. Those are defined here. The coordinate system for our model was Cartesian coordinate system. And then you have some other settings here. This is the model name. And you can see also the materials that we have used in our model. There was steel material and aluminum material. You can see the definition of the ground body, the definition of our part. If you look at the definition of the part, we have those definitions. So in the projectile here, we have the projectile body. This projectile body has a center of mass location, and it has initial velocity. If you can see, the initial velocity is right here. And also you can see that this body has markers. So we have two markers, the center of mass and the sphere marker. Also you can see that this body is using the aluminum. So all the information that we have about the projectile body, the projectile part or body, is already stored right here. Also you can see some information about the gravity. If there is other force model or force elements included in your model, it will be under this area. And then you have the measures. We created two measures, so we have the two measures are right here. And then you have some information about the geometries that we used. Now this text file, you can easily share it with other colleagues. If you build a model, you can share this model with your colleagues. But notice this text file does not contain any information. Although it has the definition of the measure. So it says you have y displacement measure, which is applied for the object projectile, looking at the characteristics, which is center of mass position, and considering only the y component. So this is our definition of the measure. As you can see in the model, the measure has data, but the text file, this command file, does not contain the information of this data. So when you store this, when you save this model as a command file, it will not contain any information about the results. If you would like to store the information with the results, then you can save your model as a database, which will contain everything about the graphics analysis and the results that you created. Okay, so now assume you have created a command file, and you have this command file, or you have this command file from a friend or a colleague who is doing this analysis. How can we open this command file? I can go to File, and I can choose Import. Now this window, the file import window, usually we use it to import different files, graphics, analysis results, and even a full model. We will learn later on how can we use it to import an assembly from SolidWorks. For now, what we would like to do, everyone will be able to load an Adams View command file. So the way we do this, we will right click on this area, file to read, and select browse. When we select browse, it's going to open the same directory that we have, or if you have your file in a different directory, you can select it. So this is our projectile command file. Click on it, the name appears here, so I will select open. I'm not going to change anything here, I'm going just to keep it as is and click OK. If you have any model and you are going to import the model, this is the process that you go through. From the file, you can select import and then define the file name and click OK. Now, because we already have all of those elements are already in the model, so MATLAB was giving me those errors. I'm going to ignore them and I'm going to use this model right now. What we would like to do is to check that our model is working and the model that we uploaded or imported is the same as the one that we just saved before. In order to do this, I'm going to simulation and I'm going to click on simulation. As you can see, the simulation was not saved, the simulation parameter was not saved. So I'm going to set the end time to 1 second and I'm going to choose, instead of using steps, I'm going to choose the step size. So I will click on this button, drop down menu and select the step size and make the step size 0.01 second. Now if you click on this play button to start the simulation, we will see that Adams is going to generate the equations required and then it will start solving those equations. The progress bar is showing the progress of your simulation here and the measure is showing the displacement in the y direction. So now as you can see, the body, the projectile is outside the frame of our work, of our site. So now, because we already solved our model, we would like to see the animation. In order to see the animation, we have two ways. One way, we can, from the animation control, simulation control window, we can click on this film strip. So this film strip is going to open a new window called animation controls. The same window can be activated from this tab, results. You can see here we have different icons. One of them is the animation controls dialog box here. If I click it, it should open this animation controls for us. I will take a moment to look at this animation controls. In the first line here, as you can see, those are similar to any buttons that you will see in a remote control or you will see in a movie player or CD player. So you can recognize this will be moving the animation forward, this will be moving the animation backward, and this one is going to stop the animation. Also you can see this one is going to have fast forward, this one is going to have fast backward, and this one is going to reset the animation to the beginning of the animation. Here we have this slider is actually used to control the position of your animation from the beginning till the end. So you can assume at this end is a time at the beginning of the time, in our case is 0, and this end will be the end of the time, which in our case 1 second. If you drag this slider, it will give you different frames. So we had our simulation from 0 second to 1 second, which you can see here, the time range from 0 to 1. And we had increment 0.01, which means in general we will have around 100 points. So if you look at the frame number here, this is the frame number 1, and if you move the slider, if you drag the slider, it's giving you the frame number. So the last frame is 101. Why 101? Because you count from 0 to 1 with increment 0.01. If you divide the time difference by delta t, this will give you 1 over 0.01, which is 100. Plus the start, this will give you 101 steps. Now, in order to run this animation, as you can see, you can click on this play button. So the play button is going to run the animation from the beginning till the end. So now it reached the end position. I would like to reset it back, so I can click on this button, so it will bring the animation to frame number 1. If you would like to see the animation in a slow motion, you can have this increment frame by frame. So as you can see, every frame you click, you can watch the motion of your body. But I don't see the body, so I would like to zoom out a little bit. So in order to zoom out, I'm going to use this magnifier, or from your keyboard you can press the key, the Z key, which is for zooming. This will change your mouse cursor into this magnifier. So I'm going to zoom out. You click on the left button and drag down. So you can see we are zooming out. If you would like to zoom in, you can drag up. So you can drag in and you can drag down or up until you see sufficient details about your model, and then you can drag the model by itself. So I'm going to drag the model using this hand, or from the keyboard you can click on the button T for translation. Now you can see the cursor have changed. I'm going to drag the cursor like this. Now if we run the animation, you can see the object is flying and then falling down. I can see I still need to move it up a little bit. So I'm going to adjust it up like this. And I'm going to pull this measure down. So run the animation again. You can see the object is flying, and you can see the full range of motion of your object. Okay, so this is about this part. Now you can see here, this is right here you can see the analysis that we did, which view we are looking for. So this is front view, and we are looking at relative to a fixed base. We'll talk about those later on. And here there is something nice. It's called no trace. So if we open this menu a little bit, you can see there is something called trace marker. Yes, Mazen? This no trace will allow you to trace markers on the body. So if you click here, you can see the other option is to trace a marker. So I'm going to select trace a marker. Now, which marker do you want to trace? Adams is going to allow you to select which marker you want to trace. So now how can I specify the marker? You can right click over here, and here as you can see marker, because Adams is expecting a marker, so it is asking you which marker do you want me to trace for you. If you see the marker, you can select pick. If you would like to select the marker from the tree, you can select browse. If you have a few items in your model, you can select guesses. So Adams right now understands that we have only two markers in this mechanism, in this system. Either the projectile center of mass or the projectile sphere. So you can select the projectile center of mass like this. Or if I choose to browse, right click here, marker, browse. This browse, as you can see, it opens the model tree for us. So you can see our projectile model is here. The projectile model has a part called the projectile. If you have other parts, they are going to be listed here. So I have the projectile. This part contains those two markers, the sphere center and the center of mass. If you have other markers, they are going to be listed here. So in this case, I'm going to select the sphere center. This is what I'm interested in. Now, let's go back to when I asked you to rename every entity that you are going to use. When the time comes to select something like this, it will be easy for you to select something that has meaningful name. By default, Adams is going to call those markers marker 1, marker 2, marker 3, marker 4. So if you don't know which marker you are interested in, you will not be able to select it. The same for the parts. You will have part 1, part 2, part 3. If you don't give every part a meaningful name, you will not be able to recognize which is which. So we're going to select sphere center, and then I will click OK. So the sphere center is selected here. So now if I run the animation, as you can see, the trace of the marker is plotted at every time, as you can see. So this marker, this trace is showing how the projectile is moving in our space, in the X and the Y direction. And notice also this is different. This plot is different from this plot. This plot is actually the displacement in the Y and X. So the horizontal X-axis here is the displacement in the X-axis. The displacement here represents the displacement in the Y. While in this measure, the measure is defining the displacement in the Y-axis relative to the time. So here we have the time is on the X-axis and the displacement, the Y displacement in the Y-axis here. While over here, this is the motion with respect to our coordinate system, X-axis and Y-axis. So going back after creating this trace, going back here, you can see the time range. This animation by default is going to display the animation from the initial time to the final time. If you are interested in specific period of the motion, you can specify the time range in this area here, or you can specify frame of ranges. For example, if we have 110 steps, 101 steps, I can specify only I would like to have the time is the steps that will be between, say, 30 to 40. So I can specify the time range or the frame range. Now, over here it says how many cycles. How many cycles do you want to show? You can select one cycle of the motion, or you can select, say, 3 cycles. So what is going to happen now? Adams is going to show this animation 3 times. So if I run this animation, this is the first time, second time, and third time. Also, you can specify the frame increment. Sometimes we use very small time step in order to capture very high speed events. And this will generate large number of frames, maybe 2,000 frames, 10,000 frames. So if you run the animation with the 10,000 frames, it will take very long period of time to animate. So instead of drawing every frame, I can select a frame increment. In our case here we have 110 frames, and I can select the frame increment, say 5. So what is going to happen? Adams is going to start from time equal to 0, frame number 1, and then increment by 5 frames, 5 frames, 5 frames, and so on. So as you will see even the animation is going to appear much faster. You cannot even capture it in your screen. So this is a very useful tool if we are interested in a few number of frames rather than having all the frames again. Okay, let me put this number of cycles again to 1, and let's look at this superimpose. If you look at the superimpose, and if you check this box and run the animation, see what happened. At every frame that Adams plotted or Adams drawn, Adams is going to keep that frame and build the next one. Sometimes this feature is useful if you are interested in learning or studying the range of motion for certain applications. Or sometimes you will be interested in learning about the working envelope for certain mechanism. If you have a robotic arm and you are interested in looking at the reach of this arm in different direction. So this superimpose is going to create this way is going to create the volume that your robot arm is going to cover within this specified motion. So this superimpose is going to draw the frame and keep the results that we have. In a situation like this, it might be useful because we use the time increment is equal to 5. But if we use time increment equal to 1, you can see it's going to be really doesn't mean anything.
دكتور الصوت يتقطع.
So let me first remove this superimpose and run the simulation again. So you can see only we have the trace of our marker. Now, what is the difference between animation and simulation? In the simulation, the program is going to generate all the governing equation of the system and then solve the equations of your system. And this process is mathematically intensive and computationally intensive. It takes time from the computer resources. Depending on the complexity of the model, how many parts you have, depending on the forces that you have in the model, the simulation may take hours in order to solve the system equations. When the system equations are solved, the results will be stored in the program, either intermediate file or external results file. One of the post-processing processes is to animate the model. What is animation? Actually is the graphical representation of the model at different positions, at different frames, at different time steps. We would like to look at how the components of the system are interacting with each other, how the parts are moving. So this is one of the post-processing techniques or processes, is to animate the model. Other processes, looking at the reaction, plotting the reactions, exporting data, exporting forces, and so on. The animation may not be as computationally intensive as the simulation, and the animation usually will not take much time as the simulation. So in many times we create the measure, and we typically don't want to see the measure covering our model or covering our screen. So we close the graphics strip for the measure. But after we run the simulation, we would like to show this measure again. In order to show the measure, you can see we have in this tree, we have measures are here, and you can see we have the Y displacement measure. But I cannot really display it. In order to display this measure, we go to View, and the third item in this menu is called Measures. So now if you click on Measures, it will display the browser. It says Database Navigator, and over here it displays the measures that we have. All the measures that we will have will be displayed here. So again, we name them. So we named only one. This is the one that we would like to display. So I will click OK. So it opens the strip, the graphics strip for this measure, like this. So now, as you can see, you cannot really customize this graphics strip too much. It's not easy to deal with. There is no menus or items or anything that we can really do here. If I would like to open the grid or change the scale or change the number of ticks or anything like this, you cannot really do it here. So what do we do? You can right click on the measure itself, and from this menu you can say transfer to full plot. What does this mean? It's going to take this simple plot and transfer it to the full plotting window. So this is one way to open the plotting window. In order to open the plotting window, we have several ways. One way, I can right click on the measure and select transfer to full plot. Okay, but sometimes I don't have any measures. What should I do? If you remember, when we had this simulation window, down here, this is the film strip that opened the animation, and right here, this is going to open the plotting window. So you click on this, it's going to open the plotting window for us. To be more systematic, under the Results tab, you see this icon is actually for opening the Adams post-processor, including the plotting. So I'm going to click right here. It's going to open the plotting window for us. Because this is our first time to open the plotting window, we're going to explain this in details. What can we do in this post-processing window? You can do most of the post-processing needed. Like what? You can run animation. You can load animation and run animation for the model. You can select and plot the results for most of the elements that you have. You can export the results. You can generate a report. All of this can be done here. So let's take some time and look at this plotting window and look at some details of it. I would like to start by exploring the contents of this screen here, and then we are going to describe this in details. So again, similar to any Windows program, you have the menu in the top. Here we have the standard file. You have import, export. We'll talk about those in details. You have the print, and you have close plot window. Edit, the standard undo, redo, copy and paste. And remember, those copy and paste will be also dependent or sensitive to the process that you are doing. After this, you have view, and those also are related to what you have in front of you. Depending on the window that you are opening, those commands will be able to do certain tasks. Sometimes they will be active, do some tasks, and sometimes not. And then you have plot. Here we have actually some kind of analysis. So you can do fast Fourier transform. If you have data and you would like to analyze this data, look at the frequency contents of the data, the amplitudes, you can do fast Fourier transform, and this is very important, powerful tool when we analyze actual mechanical systems. Unfortunately, this would require some background in mathematics. Body plot, you can apply filters, you can create nodes or create line specifications. Also, there is some tools that you can import in your you can implement in our plots. One of the very important tools is doing computation, so we can implement some mathematics to our plot or our results. Right here is also set of tools. Some of them will change depending on the task that you are doing. If we start from the left right here, this drop down menu, if you look at it, you can see the first item is animation. So basically, depending on what you select here, this area is going to change. So if you have animation, this will give you the animation window, and the controls right here will change. If you are doing a plotting, this actually what you see here is axes that we can generate plot. You can plot 2D, you can plot 3D or 4D. What we are going to cover here only just animation and plotting. You can also generate report, and you can plot curve in a 3D. For now, I'm going to select plotting or leave it as is right now. Right here you can see this one is to import file. This one is very important, which is basically if you are running a simulation, the results that will appear in the plot will not be updated by itself. If you changed something in the model, or you changed something in the simulation parameters, or you changed parameters in your components and did a new simulation, you can reload the new results. Reloading the new results is going to update the plots for you. Over here you can see this is called the print, so you can print your window. And right here you can see this icon, which is for do and undo, redo and undo. This icon appears with a little triangle because they are showing only one button. So in order to show the other button, you right click on the icon. As you can see, those three icons here, as they appear, they are related to animations. This is for the selection icon. You can add text, and this one is we use it to create line specification. This one we use it to trace or pick the value of a point on the curve, and this will We'll talk about those later on. This tool here is we use it to edit the curve. This one we use it to zoom on a curve, and this one we use it to fit the curve. We can move the curve or displace or drag the curve over the window. Those are related to the pages. So what is page? As you can see here under projectile, we have our model. Those are the analyses that we have. And then you have page 1. This page is referring to this area right here. The page can contain multiple plots. Right now we have only one plot. So how do I create multiple plots? Here you can create a new page or delete an existing page. In order to create multiple plots, you can change the layout of this the page from. So you look at this. This is going to change the layout of your page. How can we do this? As you can see, we have this little triangle. You right click on it, and here you see different arrangements for the layouts. So you can have one plot in the page, you can have two plots side by side, you can have two plots above each other, you can have three plots arranged in different arrangements, or multiple plots if you wish. Just for now, I'm going to choose those two pages, side by side pages. So if you click on this, let's do it again. I will right click on this icon and select the side by side plot. As you can see, the page have been split into two parts, left and right. The control is given to either one of them. The one that is active and under control, you will see it have this red frame. If you would like to choose the other control, the other area, you can click on it, then it becomes, the red frame will transfer to it. Or you can select from the page, you can select which plot you are referring to. So once you click on the plot, you can see the frame is moving from one to another. What I would like to do is to have animation in this area, and I would like to have plot in this area. So what we are going to do today actually is we are going to display animation in this area, and we are going to do plot in this area. Now, as you can see, in this area over here, we see that we are loading the analysis results from the last run. We don't have a specific name for this run, so it appears as last run. Down here, it appears something called source. And the source is actually pointing to a drop-down menu. And the drop-down menu, you can see measures. Now, in this area here, we have only one measure that we used in our model. So you can see Y displacement. Now, you can select the measure from here, or you can look at other entities in the model. So if you click on this drop-down menu, you will see objects or result sets. I'm going to select objects. When you select the objects, you will see the layout changed a little bit. So now you have bodies. You click on the bodies, and then forces, constraints, Bodies will list all the bodies right here. If you have forces in the model, they are going to appear right here. Constraints mainly will be for joints and something like that. If you have motion, it will appear also here. Right now I have only the body projectile. So I'm going to select the projectile. If you click on the projectile, you can see the characteristics of the body. And notice also those are the characteristics of the part itself. So you have in the part, you have the center of mass, position, velocity and acceleration. You have the center of mass, angular velocity and angular acceleration. The part have kinematic energy. The part has kinetic energy, translational kinetic energy and rotational kinetic energy. And you have other things here. If you expand this projectile, you can see all the elements on the projectile. This projectile have only two markers, the center of mass marker and the sphere center. Right now I'm not interested in the marker, I'm interested in the projectile itself. So what I would like to do is to plot the center of mass position. So I'm going to select from the characteristics, I'm going to select the center of mass position. And I would like to select the center of mass displacement in the x direction. So if you click on the center of mass x here, now you can select the add curve. But let's start by y. So I'm going to select the component y, and I'm going to select add curve. When I click on add curve, the plot is going to be generated in the region that was selected, and the plot automatically has all the elements that we usually see in typical plot. Other components, you can select the displacement in Z or the magnitude of the displacement. I'm going to focus right now only on this part of our motion, which is the Y displacement. Now, if you click inside the plot, it will be highlighted here. If you expand this plot 1, you will see that there is some other elements that we can talk about. If we start by plot 1, you can see plot 1, you can change it if you wish. You can change the name of plot 1 by choosing to right click. So you click on it and click again, and you can input a name. So I'm going to call this Y center of mass, Y or center of mass position, like this. After you change the name, you hit enter. So now this part is the center of mass. But this does not change anything in the window. This is only for the title. So when I come back and look at the plots, I will know which plot I'm looking for. You can have a plot for the center of mass position, another plot for the center of mass velocity, another plot for the center of mass acceleration. You can have reactions and so on. So from the plot name, you can choose, you can predict what it will contain. Now, as you can see, here we have some kind of information or properties that we can choose here. So here you can have the title is projectile 1. You can change this if you wish. You can have axis. You can have analysis. You can have those things that you can change. You can go to every one of them and change it right here. So for example, if I would like to change this title, I'm going to make it center of mass position. So I can go to title here, click on it, and you can see the name appears here. By default, it's going to say the model name. In order to change this, double click and then type the new name that you would like to have. Center of mass, position. Also, you can select the where do you want to place it, horizontally or vertically. The font size, if you would like to make it bigger, for example 12, notice it changes directly. If you wish to center the title, which is most of the cases will be centered, or you wish to make it in the left, the right, better have it in the center. You can also select a color, so you can select this color if you wish. You can select red if you want to go to red. Here is red. So this is the title right here. How about this analysis and the date? As you can see, the date appears right here. If you don't want to have the date to appear, you can just remove it. So how do I remove it? You can go to the page right here and select the date stamp. Date stamp is going to remove the date for us. And notice also we have the analysis. Sometimes for the same model, we do several analyses and load them. For example, if you are simulating a car, say you can do a straight drive car, or drive over a bump, drive over a hole. You can make U-turn, they call it J-turn. You can make S-shape or U-shape, or you can make braking, accelerating simulations. So the analysis name can be indicator. If you wish to include it, you can include it here. If you don't wish, you can remove it right here. Also, you can have the legend. This is the legend. So you can include it or remove it. The zero line is this line. You can include it or remove it. Most of our applications, we would like to have the zero line. So now I have this window. I'm going to show more details about it. So here is the title. We define the title. And now we have the curve. This curve, as you can see, has a name which appears in the legend. This name right here is what appears in the legend. Now, as you can see, this name is too long. So I can change the name. Instead of projectile.cm.center of mass, I can make it center of mass cm_y displacement. That's it. This is all what I need. And you can choose the color. You can choose any color you want. You can also select the type of your line. So here the line is solid. I can change this to make it, for example, dotted, or I can make it dash dot, or I can make it dashed. If you have multiple plots, multiple curves in the same plot, you can change each one individual like this. The weight defines the thickness of your line, so you can make it thicker as you wish. You can also add symbols. If you have more than one curve, you can add symbol for each curve. So here I'm going to use solid line, and as you can see, the symbol appears right here. If you are using X, you can use circles, you can use dots, or you can choose the ones that will fit with your application. When you have too many points, the symbols are going to overlap, so you can add every five points we will add one symbol like this. So you have here after 5 points, after 5 points, and so on. So now we have looked at the title, we looked at the curve. Now, what if you would like to change the range of your x-axis and y-axis? So here, h-axis is the horizontal axis. The horizontal axis, you click on it, it will give you this properties. You can change all of them. Right now, Adams is selecting the limits of your axis automatically. So you have auto scale. If you would like to change the auto scale, you can say, for example, I would like to look at the simulation until this time, say 0.75. So you unselect this. The limit is from 0 to 0.75, like this. So now this is our x-axis from 0 to 0.75. You can also change the limit. So you can change the limits if you wish. You can select the type of scale. Right now, as you can see, the scale is linear. Here, the scale is linear. What does it mean? Scale linear means, it means the distance between every two ticks is equal. You can select log, this is the log, or you can select dB, this is the dB. In general, for the x-axis, most of the time will be the time, and it will appear to be linear. Would like to look at the linear in time. You can also format. You can format the x-axis. You can format the title. So instead of time in second, I'm going to make it s only, not second, like this. You can also change the size of the font. So I'm going to make it 8, so it becomes smaller. You can also select the position of this. You can select the color, so you can use, say, for example, blue if you wish. So anything here can be selected. Also, you can select the text, those texts, how many do you want to have. So let me add between those two minor divisions, I'm going to add, say, 4 divisions, like this. So this would be like 0.05, 0.1, if we make it 5, 0.05, 0.1, 0.15, 0.2, and then we have 0.25, 0.3, 3.5, 4, 4.5, and then 5. So you can select the number of text from here. Also, you can select the color of text if you wish. So you have full customization of those texts. The same applies to the vertical axis. So you can change the vertical axis. You can go to the scale. You define the limits of the vertical axis. You can define linear or log if you wish to do whatever values you want. You can define the label. So instead of using length, I'm not interested. This is not the length. This is, we are going to call this projectile attitude, or let's call it projectile displacement. And this displacement is in millimeter, so we'll leave the millimeter as is. You can also change the text if you want to add more text or less text. It's up to you. So this is how can we control this graph. The legend, this legend, you can display it or hide it. So you can hide it if you wish. You can click on the legend and hide it if you wish, like this. You can add border line or remove it. And you add background or remove the background. This is the standard that you will see in most of the cases, but if you wish to change something, you can do that. Now assume in this plot I would like also to show the x-axis displacement. How can I do that? I can go and select the component that I would like to add. In this case I would like to add x. So I will click on x and choose add curve. So what happened? Adams added the same curve, added the curve to the same plot. So you can see now you have the y displacement and you have this new curve. This new curve, as you can see, appeared also under the same page. So we have curve 1, I can rename it. So this curve 1 is y displacement. Y displacement. Curve 2 is x displacement. Now, as you can see, so now we added this new curve. And it seems like I cannot have too much to work here. I would like to expand this curve until I fit it and then bring back the other window. What I'm saying, I would like to expand this window or this part of the screen on the full screen. Right here, this icon will allow you to expand this part of the layout. You click on it like this, it will expand this part of the layout. You want to fit it back to the same size before, you can click it again. So this is going to fit our plot in the full window. We are going to keep it fitted like this until we finish our customization. So now I would like to change this curve. I would like to make it solid and change the color to black. I can select the curve from here or select it from here. You select any one of the curves, it will appear in the list of curves here. So I'm going to select the curve 2 or x displacement, change the curve name here, make it x displacement, and then in the legend I'm going to make it similar to the y displacement. So I'm going to change the legend name, delete this, make it C, center of mass, x displacement. So again, as you can see, it appeared right here. Now, as you can see, we would like also to change the color. We would like to make it black. So I'm going to click on the color and go scroll up to black. And I would like to make it solid. So I'm going to select solid line. You can also select a symbol. So here we have the symbol is circle. So instead of circle, I'm going to select this star. And instead of displaying a star for every point, I'm going to select a star for every 5 points. Like this. So we have a star right here for every 5 points. So now, as you can see, I had full customization for my plot. You can also change the position of the legend. In a curve like this position is good. Sometimes you would like to make it down or up, so you can click on legend right here and then select the position. So you can make it top left or bottom left or top right or bottom right. I usually keep it in the area that is not covering my curve, so this will be a good area. You can also select the font size. If you see it's covering a lot of your area, then you can make it smaller. If you have enough space, you can make it bigger. Now, assume I am interested in looking at certain part of the curve. How do I do that? I would like to look at this area here. because this will represent the maximum displacement, I would like to see what is happening at this area. I can zoom on certain part of the curve using this tool right here. So if I click on this tool, I can create a rectangle around the area that I would like to do, and then release. How do I create this rectangle? I will click on the tool and then come to the corner where I would like to start my rectangle and click on the left button and keep pressed, and then drag until you have all the areas that you would like to zoom in. I'm going to zoom in this area, then you release. If this is the area that you are interested in, then you can start your analysis. If you would like to zoom more, you can do it again. You click on the tool, and then you, at the start of the corner of your rectangle, either from left or right, so you can click and keep pressing the left button and drag a rectangle around the area of your interest. When you reach the other end of your rectangle, just release the button, you will get the curve in this area. Now, what is this value? How much is this value exactly? Oh, you can read it from here, but I wanted to have it exactly. So you can have this tool, we use it for plot tracking. If you click on this tool, it will give you those statistics about this curve. This tool is going to show this crosshair. See this hair? And this hair is moving over every step from your simulation. So you can move your cursor to the left or to the right. The point is going to track the simulation points that we have. What is the value that we are interested in? It will appear on this ribbon right here. So in this ribbon you have the value of the x-axis. In our case, this is the time. So this is the value of the time, which will be in seconds. And in the y represent the displacement of the projectile, and the y-axis, the attitude of the projectile. So this value will appear here. And Adams is going to do some more calculations for you. So it's going to give you the slope at the point, the minimum of the curve, the maximum of the curve, and the average. Those are kind of interesting values. We can use them sometimes to look at certain characteristics of this curve. During this range from here to here, as you can see, the minimum value is right here. And Adams is telling you this minimum value is 510. The maximum value at this point, this is the point that we are interested in. We would like to see what is the highest amplitude. So from this, you can move the crosshair until you come to this area. So you can read the value of y from here, which represents the attitude, and the value of the time at which this attitude is happening here. So now I can read the values from x 0.36, and from y it's 637.127. This is exactly where we are reaching the peak before the projectile starts to fall down. Also, Adams is telling you inside this area we have 30 points. So you have from 1, 2, 3, 4, 5, 31 points. Now, I traced the values here. I would like to see how much was x at the highest value. So I need to display the curve again at the same scale. So I can click on this icon here. It's going to fit the axis for me. So click, you get this axis right here. Now I'm going to pick the tool tracking again, the plot tracking. Now, as you can see, I have two curves. Which one of them should I use? Oh, the one that is closer to your cursor is appearing. So you remember our highest altitude at 0.36. So you can have, this is 0.36. You can move your cursor up. As you can see, the small circle moved up with me to the second curve. You can read this from the second curve. So in the second curve, you can read the value of y. So at 0.36, this is 0.36, the value of the y displacement is 637. The value of the x displacement is 1272 millimeters. Once you are done with your values, you can also see when the projectile is going to hit the ground right here. So this is where our projectile is going to hit the ground. This will happen at 7.72 seconds. Once you are done, you can click on this icon here. Your plot will come back to the regular plot. So now we are almost done with all the analysis that we need from this plot. So I can reduce the size again to the original layout size. I can click on this icon again right here. So it will fit it back to its original position. Okay, so the second part here, we said we are going to make this half of the plot or the page, we are going to display animation. So how can we do that? The first step is to select this part of our page. If I click on this part of the page, you can see the red frame has moved to this area. Or you can select from the tree right here. You click on the tree, it will highlight the area, and you can actually change the properties of this area. The first property that I'm going to change is actually animation. So I'm going to call this the title. I'm going to call it system animation. How can I change the name? I select first and then click. As you can see, it is blinking. So I'm going to call this override system underscore animation and hit enter. Now, before doing anything, I will go to this drop down menu and select animation. Click on the drop down menu, go to the. So how do we convert this area into an animation? As we said, we will click on this page, and from this drop down menu, click on this arrow and select animation. What this is going to do, it's going to change the type of this area. As you can see now, it looks like the same as the pre-processing area. And also the icons and the layout right here have changed. Right here you can see the icons for view. So now what we will do is basically load our model in this area. How do I load the model in this area? Down here, you see this overlay tab. Again, you can see all those tabs. Every tab will contain different functionality. So we're going to click on this overlay tab. Okay, so we will click on this overlay tab. You will see the model name right here. So this is our model name is Projectile. We have only one analysis, which is last run. So I'm going to click on this last run. Once you click on last run, you will see the projectile appeared here. Again, it's fitting the screen, so which means this size is too much for us. So what will we do? We would like to zoom out a little bit. How can we zoom in and zoom out? As we did before, the same as the way we did before. You can use the Z key in your keyboard and then press on the left button and drag. This will zoom out like this. Again, once it appears, you can zoom out and zoom in. How do I zoom out? You can press on the Z button in your keyboard. The cursor will change and it will become like the magnifier. You click on the left button and drag down, it will zoom out. Now I would like to translate the model in the left so that we can look at the full motion. So in order to translate, you can use the hand, or you can press the T button from your keyboard. If you press the hand or T button, you will get this new translating icon. So you can drag my model right here. Now I can see this will be sufficient. I hope this will be sufficient to see the full motion. I can test that. In order to run the animation, you have this button right here, or those buttons right here. So I'm going to click on this button. As you can see, the system is moving and it reaches, oh, it's actually going outside the range, which means I need to zoom out a little bit more. So I'm going to zoom just a little bit. Then I will reset the animation again, run the animation. As you can see, it goes all the way, and just sufficient for our simulation. While the animation is working, you can notice this crosshair, and you can see that this crosshair is synchronized with the system motion. So you can see the displacement in X, the displacement in Y, along with the displacement, the time motion of your. If you would like to record the animation, you can click on this record button. So first we set the animation to the beginning, record, run the animation. So what is happening now, Adams is going to capture the motion of our projectile along with this curve. So what you will see from this animation, actually the projectile moving and the plot is also captured. So you can really see this nice synchronized motion. You can control the parameters of your generated animation, and we'll talk about this later on. But for now, we are going just to generate this animation with all the default parameters. So Adams is generating this motion, this AVI, using the default parameters. It's done. Once it is done, it's going to be stored in your computer. Again, if you would like to store this animation, you can run the simulation, run the animation, hit the record. This record is going to record every frame into an AVI frame. You can run the full simulation and record the full simulation, or you can record part of it. And I will show you later on how can we control part of the animation. Once you are done with the recording, you can stop. You can stop from here. What happened now, Adams have already created animation for us. Where is this animation? It will be saved in the directory where we have our model saved. So if you go to your directory, you can see projectile1.avi. This AVI, you can directly open it by any Windows Media Player, or you can open it with, I think it would be even compatible with QuickTime Player and so on. So you can open the AVI using your preferred player. So I'm going to use Windows Media Player here. So this is our animation appeared in the media player. As you can see, I have the projectile is moving, and also you can see the plot. The motion of the projectile is also synchronized with the crosshair motion over the plot. You can share this with your analysts or your friends or so on.